Okay. One more thing we want to see, guys, right now is the ARP thing again. I want to show you the ARP thing briefly before we, you know, continue, because we have to see ARP, Gratuitous ARP, RARP, and Proxy ARP. So ARP is very simple. We had the network over here. If I just change the show ARP, I already have a entry, but let me just change the IP address here and it should work. What is this IP? 10.1.1. Okay, so if I change the IP config t, IP add 10.1.1.3 255.0.0.0, and I put it in simulation. If I try to ping from here, ping 10.1.1.3, it is going to generate a ARP because it does not have it doesn't know that the same MAC address has now a new IP. So basically it is thinking that this IP might be a new one in the network. So it sends out a broadcast to everybody. We can see the broadcast here, over here. We can see the broadcast. Oops, where did that thing go? Yeah. Let's see the broadcast. This is the packet in detail. It says I'm coming from this guy. I'm going FFF 12 times FFF is broadcast MAC address. It says I'm going to reach out to everybody in the network, and I want the MAC address of this guy 10.1.3. So let's say 10.1.3 belongs to Braven. So Braven, everybody is going to reply, see the packet, but nobody is going to reply. Actually, I just have two devices in this network, so this is not the best thing to do. Uh, it would be better if I use it here. Um, what's the IP here? No IP, no IP, no IP. Let me just give them IPs to generate a ARP. Desktop 10.1.1. Subnet mask is fine. Guys, just before I complete ARP, this is a gratuitous ARP packet where whenever we assign a new IP address in the network. So we are going to see that, but just before I complete gratuitous ARP, let's finish this ARP thing very quickly. And this is a gratuitous ARP real time. Let me come here, do a ping from this PC to this PC. It says this is coming from Aman going to Bravin. My IP is this. Everybody in the network should get a copy of this packet because it is broadcast. Yeah. So this PC also gets a copy of the packet because let's say this PC belongs to Sarthak. He sees the IP address 10.1.3. It says this does not belong to me because I'm 10.1.2. So that is not me. Bravin sees the packet, but he doesn't reply a broadcast. He says it came from me, from a man, so I'm going to reply. He got the MAC address from here, put that into destination here. He put his own MAC address and sent it out. So that is ARP. I think we have done ARP very well. He replies to me, and I maintain an ARP table, and now I can ping successfully to this guy. No issues here. If I go into real mode, on a PC, you can see the ARP table with the command ARP/A. I can see I've got this PC's IP and this belongs to Braven. So I'm just using Braven for this thing. Do you get it, Braven? ARP thing?
Yeah, so is the -A is that referring to it being the gratuitous ARP
No,
versus
this is just normal ARP table. This is not the gratuitous ARP. We'll see the gratuitous ARP right now. Let's say this PC uh, one gets a IP. It takes a IP, right? If it takes a IP, let's say it tries to assign the same IP as me, right? Let me put this in simulation first. Oh, it says 10.1.1 and it tries to get the same IP as me. What happens? A gratuitous ARP packet is generated and it basically sends the source is also 10.1.1, destination is 10.1.1, and it sends it out to everybody in the network. Let's see what happens. It goes to me and Braven. Braven sees the packet and he just drops it. But I send a packet and I say, no, 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 don't take 10.1.1. That belongs to me. And I reply that packet here. And this one drops the packet, It says, when once it gets the packet, let's see, and I say 10.1.1 from me and destination to this MAC address, and I'm telling you don't get this IP address. So it is just like a duplicate address discovery, and when I send that packet, you get this error message. This address is already used in the network. Guys, did you get gratuitous ARP? I just told you about. Like it checks the duplicacy by sending a broadcast to the same uh, IP address which it wants to assign to itself. Like if I try to assign 10.1.3, it will be sent as a broadcast to everybody in the network, and Braven will reply that please don't take this IP address, this belongs to me. Are you getting my point?
yeah, that's the gratuitous.
Yeah.
What was the other ARP that you used just to
Yeah.
get the MAC address in the first place?
Yeah, so that was a normal ARP to get the MAC address of another device, which is a different address. That is a normal ARP. This is gratuitous ARP. Are you getting the difference between both of them?
Yeah, how many different types of ARP are there?
I mean, not really. Can you explain again the gratuitous ARP?
Let see, gratuitous ARP is like, let's say my IP is 10.1.1, right? So in ARP, what I did was I said who is 10.1.1, and I got a I someone sent let's say I said sent a packet saying who is 10.1.3. It goes to you, it goes to Braven. Braven sees that packet, you see that packet, and you say, this packet is not meant for me, because your IP is 10.1.2. Braven sees that packet and he replies a unicast message to me saying, my MAC address is this, right? So it's just like walking into a room and saying, who is 10.1.3? And only the guy who is 10.1.3 will reply, this is my MAC address, and you can have my MAC address. You get my point?
Yeah, now I understood it a
Okay.
little bit.
And now gratuitous ARP is also like walking into a room, but instead of saying who is 10.1.3, I'm saying, does anybody have like, I am going to allot 10.1.1 to me. Does anybody else have 10.1.1? It goes to you, you don't reply. It goes to another person, he doesn't reply. And therefore I can allot it. But let's say if there is already a person sitting in the room who has the IP address 10.1.1, and I go and say, I'm going to allot this IP address. So obviously he's going to reply and say, please don't do that. This belongs to me, right?
Right. So you can send that out without having an IP address yet, because you're trying to figure out if you can allot it to yourself.
Yeah. So instead of like not putting any IP address, I'm going to put the source IP address as 10.1.1 and destination also 10.1.1. When you see that packet, you match it with your IP address, and that is 10.1.3. You don't process, you just discard the packet. You don't reply. Sarthak also sees his IP is 10.1.2. He doesn't reply. So if there is nobody in the room with the same IP, I'm not going to get a reply, and therefore I can allot that to myself. But if someone else, like let's say Stephanie, sees that packet and she says, wait, this packet belongs, this IP address belongs to me. So I cannot allot that to myself, right? Once I get a reply from her, right?
Right.
Okay. That is gratuitous ARP, okay?
Cool.
And once she
So what's
replies
the
that,
key? What's the one key difference between regular ARP? Because ARP just um, gets the IP address and the MAC address of the other thing. What's the
see,
key
yeah,
difference
ARP
here?
gets the MAC address of this, and gratuitous ARP is basically checking if this IP has been already allocated to some MAC address or some, some person inside the room. So it is very similar. The only difference is in the first one, you actually did not have a MAC address, so you're trying to fetch the MAC address. In the second one, gratuitous ARP, you're checking if someone else has the IP address or not. Okay. Just think of a room like this. Okay, I think you have understood this. Just think of this room. Now we talk about reverse ARP. What do you think is reverse ARP?
Telling the other devices what your MAC address is or your IP address is.
No, reverse ARP is just the opposite of like in ARP we were getting MAC addresses, MAC address for a single IP. In reverse ARP we are going to get our, like if we don't have our own IP address, we will ask a reverse ARP server that can you give me my IP address? How can we do that? Any idea? So before DSCP, there were other protocols to assign an IP address. First, there was reverse ARP. Later came Bootstrap protocol. How do we do reverse ARP? Very simple. Reverse ARP uses the same packets but for a different reason. We use reverse ARP to figure out what our own IP address is, right? Let's say there is I have an IP address and it has been allocated. Someone in the network, let me go back to the network. Someone in the network is going to keep a copy of this thing. So let's say Braven already knows what the IP address of, what my IP address is. How? Because he has this copy. He has this maintained, right? He has this table. It says 10.1.1 has this MAC address. You get my point?
So what's the difference between that and um, using the 127 like feedback loop to get your own information?
No, feedback ping 127 is just checking if your NIC card is working or not. This is not
Oh,
your
yeah, yeah.
IP address. This is just checking your
That's
NIC
right.
card. Okay.
Gotcha. Yeah, yeah, yeah.
Okay. Now you are already, so there is going to be a reverse ARP server in the network over here. Let's say there is a server and it maintains an entry, like for every IP address it has an entry of the for every MAC address it has the entry of IP addresses. It maintains a table. Now I come inside the room. Let's say I just walk inside the room over here, and 2 3 people are like into this meeting. I say my name is Aman, and does anyone know my IP address? How can you answer? Braven, you have the answer to that question. How can you answer that question?
If anybody else has my same name, you say?
I say, like, let's say I walk into the room and I say my name is Aman, or my MAC address is 0060 5C1758D8. This is my MAC address. Does anybody know my IP address? You can reply to that answer, can't you?
Yeah, you use the gratuitous ARP.
Like looking at, because you already have a ARP table and you know what my IP address is because you got this before, right?
Yeah.
So if you receive a packet saying, does anybody know the MAC address of 00, sorry, does anybody know the IP address of 006057 whatever the MAC address is? You can send a packet saying, yeah, I know the MAC address of this, and you can just reply to me, right? But for
Yeah.
this to work, yeah, there must be already a ARP table maintained by a reverse ARP server, and it should maintain a table, and your entry should be in there. Like my entry is already there, right?
Okay.
Yeah. So because I have already communicated with you, uh, you have my entry, and you can give me your my IP address, right?
Yes.
Uh, so
I'm
yeah.
wondering though if it's if you have if it's not static, it's a dynamic and it changes, does it automatically change in the server?
See
The
if
server that the server
yeah,
that
if
records all the IP addresses and MAC addresses?
it doesn't really bother about like static or it should be like, if someone has, because if I am asking for my Mac my IP address, most probably someone has already put it in statically, like let's say 5 devices are going to be connected in a network, right?
Okay.
Let's put this example. Let's say 5 devices are going to be connected into this network, right? And I don't want anybody to be, I want something called zero touch configuration. I send in an engineer to install a server one day before. He statically sets the IP address for uh, every MAC address in the reverse ARP table, right?
Okay,
When
cool.
these, yeah, so there is a server sitting here. Let's see. Um, there is a server sitting here. It comes up. It already has entries for Braven, Sarthak, Aman, all these 3 people. Let's say we 3 people come into the network the next day, and we send out broadcasts, and we say, my name is Aman, does anybody know my IP address? It goes to Sarthak, it goes to you as well. You don't know my IP address, so you are just going to drop that packet, and Sarthak as well. But this server, when it sees the packet, it sends a reply back and saying, oh, I know your IP address, you can have this IP address. You get my point?
So is there a way to just bypass sending a packet to everybody and go straight to the server?
Uh, Not the first time. Like the first time, just like ARP, it has to be a broadcast, because I don't know my address, my IP address. So I don't know even the server's IP address, right? I don't know anybody in the network. I'm just asking. I'm just sending out a broadcast saying, does anybody know my IP address? So what that packet will look like in the source MAC address, I would put my MAC address. In the destination MAC address, I would put 12 times F. In the source IP, I would put 4 times 0. in destination IP, I would put 4 times 0 because I don't know anybody in this network till now. Once I get an IP address, yeah.
So the packet will even make it to the router, but since the router doesn't forward packets, it'll just die there.
The route, this packet will also make it to the router because it is a broad. If this link was up, this link is down right now, so it won't go on this link. But let's assume that this link was up, so it is a broadcast packet, so that packet would go to the net router as well, but the router would just drop that packet because it is a broadcast packet, right?
Right.
Okay. This PC will also drop the packet. This laptop will also drop the packet. This server will say, oh, I already have. Someone came in one day before and statically configured your IP addresses with MAC addresses. Here is your IP address. I know your IP address. Once I know my IP address, I'll allot that IP address and, then I can communicate with all of you one unicast. No more broadcast anymore. Okay?
So you use the reverse ARP when the IP address was already statically
Yeah.
assigned.
So yeah, reverse ARP will only work if the server already knows your IP address. If the server also didn't know my IP address, so everyone in this network would drop the packet and I won't get a reply from anybody. And it's just like I walk into the room, I say, does anybody know my IP address? And no one replies. So if no one replies, I can't have IP address, right?
Okay.
So the server, someone must know my IP address and it must have been configured earlier so that I can have that IP address, right?
Okay. And did you mention something about a reverse ARP server has to be maintained beforehand?
Yeah, so here let's read this. Can you just read this, Stephanie, what I've highlighted?
Oh, this is Shanae.
Can you just read this? Hold on. Just read it loudly so that everybody can hear.
RARP is an old protocol, and we don't use it anymore to assign IP addresses to hosts. It has been replaced by VOOTP and later by DHCP. So what exactly is RARP? You probably know ARP. We use ARP to figure out the MAC address of a remote IP address that you want to reach. RARP uses the same packets, but for a different reason. We use RARP to figure out what our own IP address is. RARP was used by old diskless workstations. These old hosts don't have a disk, so there is nothing to store an IP address on. They do have a hard-coded MAC address though. When the workstation starts, it broadcasts a RARP request with its own MAC address on the same network as the host. On the same network as the host, we have a RARP server listening to the RARP request. This survey has a table that contains a combination of MAC and IP addresses. When it receives a RARP request, it checks its table to find the matching IP address for the MAC address in the RARP request packet. The RARP server then replies with a RARP reply to the host. When the host receives the RARP reply, it knows its IP address.
So this is the MAC address. It says my name is this IP 0.0. What's my IP address? This server checks its RARP table. This is the RARP table, and it says AAABBBC has this IP address. So he says your IP address is this 192.161.1.1, and it gets a reply. And this one, because it did not have like a disk before, this diskless, but you don't use RARP anymore because now we have DSCP servers that can automatically assign you IP addresses. So we don't use them anymore. But do you get the process, guys? It's two-way process, right?
Yeah, I get it.
Okay. It says, what is my IP address? And this one looks at the table. He says, this is the MAC address, matches it with the IP address, and he says, this IP address belongs to you. And he keeps, and this one allots that IP address to itself. So this is about RARP. Next thing we need to know is about Proxy ARP. Hold on. Proxy ARP, yeah. And a very good Proxy ARP solution. Proxy ARP is something very similar. And we know that a broadcast cannot travel across a router, right? Router is going to block that packet, right?
Right.
Yeah, so it is not going to let the packet go across the uh, across the across the network. I don't see this very well. Hold on. Proxy ARP.
So if it gets a request from outside of the network, it just sends its own MAC address instead of anybody within the network.
Yes. You're very close. I'm just trying to find the right image. Proxy ARP. Where's Proxy ARP? Hold on. Oops. Okay, if are you able to see this image, guys? Can you see this image?
I can see it.
Okay. Now this is in a target. It is a ARP request, and it says 10.1.1 over here. This one says I want ARP request for 10.1.2.200. So this is a network 10.1.1.0 and this is 10.1.2.0. These are two different networks, two different subnets, right guys? Are you getting my point? This is a
Yeah, I
different
follow.
subnet, this is a different subnet. Aryan, Sarthak?
Yeah,
Yeah.
go on.
Okay. Now we know that the router will not let broadcast from 10.1.1 go into the network of 10.1.2, right? Now this PC says I want it makes a ARP and it says I want the MAC address of this guy because that is what ARP is. It says I want the MAC address of this guy 10.1.2.200. This goes to everybody in the network. This PC drops the packet because obviously this is not meant for this PC. The router sees the packet and he says, oh wait, this is in a different network. You are coming from a different network and this IP address 10.1.2.200 is in a different network and you are not allowed to go to this network. This is a broadcast. So this router, normally it should drop the packet. This is what the default behavior of router is for any broadcast packet. But just for this ARP request, he sees that he is directly connected to this 10.1.200 network, 10.1.2 network that is on this side of the interface. He says you cannot go, but I can go to this side. So he changes the source MAC address, and he puts his MAC address and his IP address for the server, for this side, and sends out a ARP request. The DS this web server replies with its MAC address, gives out its MAC address. It comes to this, and then the router again forwards this packet to this PC. So ideally, a broadcast should have been dropped by the router, but since this is called proxy ARP, proxy means instead of it has he has put a proxy. Proxy very simple to understand. Like if you don't go into class, like if you're going into college or school and you don't go into class and you want your attendance to be done, you know that you are not in the class, so you ask your friend to do a proxy for you. What do you mean by proxy? He is going to put the attendance instead of you, right? So that's what router is doing here. Instead, he knows that you cannot go this side. So instead of you, he's putting his IP address and taking that packet to fetch the MAC address of this guy, 200 web server, and then re-forwarding it back to you. Are you getting the point, guys?
Yeah, that's cool. Will you be showing us on Cisco Packet Tracer?
I don't know if we can see that packet over there, but let me. I want to. There's another thing, and proxy ARP. So proxy ARP over here. Uh, oops. Okay, guys, let's see this sender's MAC address. This is the sender's MAC address, right? Uh, and his IP address is 172.16.10.100, and he is aiming for 16.20.200. So that is in a different network. So most probably it is going to reach coming from where 176.10.100, whereas 10.100 is here. Host A is sending the packet and it goes to the router right over here, and it wants to reach to this guy 20.200. That is right, 20.200. Now 20.200 is on the other side of the router. Can you see it, guys?
Yeah.
Yeah. So 20.200 is on the other side of the network, and this is a different network, and this is subnet A, this is subnet B. Now this is a broadcast host B. Host B gets the packet, that packet, and drops it because it is not meant for him. The router sees that packet and says, "Well, you cannot go to subnet B because this is a broadcast. So ideally, I should drop this packet." But what the router does instead, it changes the MAC address. Wait, the MAC address is same. It changes the sender's IP address. Sender's IP address was 16.10.100. It puts its own IP 20. Sender's IP 20.100. So request to send its map. The ARP request packet is then encapsulated and sent out of host A with a broadcast. So this is the broadcast address. Since the ARP request is a broadcast, it reaches all nodes, and which includes the E0 interface of the router, but does not reach host D. The broadcast does not reach host D because routers by default do not forward broadcast. Since the router knows that the target address is on another subnet and can reach, it replies with its own MAC address to host A. So basically, router says, if you want to reach that PC over there, this is he gives his own MAC address to this guy. Like, to reach out there, you have to reach me. That's what it is saying. Like you are telling your friend is saying, my other friend, you to put your attendance in the class, you have to reach out to your friend. The router is saying, if you want to reach subnet B, reach out to me. And he gives his. What does ARP do, guys? Do you remember what ARP does?
It's the address resolution
Yeah,
protocol.
locate IP
Yeah.
address and MAC address for the other device.
No, it fetch what kind of address it fetches? It fetches the MAC address, right?
Yep.
So ideally, it should have got this ARP should have got the MAC address of host D, because this is the MAC address of host D. But the router knows that you cannot travel to this subnet. So the router, instead of giving the MAC address of host D, it gives the MAC address of this interface E0, that is 36AB. And what happens after that? Let's see. So since the router knows it is on another subnet and can reach host D, it replies with its own MAC address to host A. So this is what the router gives you. It says this is the sender's IP address, this is target MAC, and it gives out. This is proxy ARP reply that the router sends to host A. The proxy ARP reply packet is encapsulated in an Ethernet frame with the MAC address of the router, source address, and the MAC address of host A as the destination address. The ARP replies are always unicast to the original requester, and therefore it can reach. From now on, host A forwards all packets that it wants to reach D to the MAC address this of the that is of the router. Since the router knows how to reach host D, the router forwards the packet to host D. The ARP cache on the host in subnet A is populated with MAC address of the router for all the hosts of the subnet B. Hence, all packets destined to subnet B are sent to the router, and this is the MAC cache. So every IP address on subnet B has the same MAC address of the router's this interface. Guys, can you see what is happening here? Are you able to understand? See, the router
Yeah,
knows that.
that's how
Yeah,
the two networks talk to each other.
yeah. The router knows very well that you cannot reach this site directly. What does ARP do? Like if I did a ARP to this host B, what would host B? It will reply with its MAC address. Now the router knows that you cannot reach the MAC. There's no point giving you the MAC addresses of these PCs because you cannot reach them directly. So to your ARP reply, it gives the MAC address of its E0 interface. Any packet you send to this, now you think that this PC has a MAC address of this is the MAC address of this PC, which is not the reality. The reality is this is a different MAC address. But you send the packet to the router, and the router sees that packet and forwards it because it knows how to get to this site. So basically, the router is working as a proxy or a mediator in between. Are you getting it, Stephanie?
He's a mediator. That's good. I was gonna say it acts like a messenger, but mediator is
Yeah.
better.
Yeah, both actually messenger is also a very good, instead of mediator, yeah, messenger is also good. So router acts as a messenger. You send the packets to router and router forwards it to the destination. So it acts like a proxy. Everybody, did you get the point? Sarthak, Aryan, Stephanie, Nix.
Yeah, I get it.
Okay.
Yeah, sort of.
Yeah.
I think I'll get it more, with a practical.
No,
or
just read.
as we go down the line.
Yeah, I'm going to put this link in the chat box so you can read it. Just remember
Oh, yes,
that
that'd be great.
our packet cannot, your broadcast cannot travel to this side. So you send the packet to this interface and the router forwards it to the other guys in the network. A router acts like a proxy or a mediator or a messenger for you. You get my point?
So the MAC address that the device would get would be the router's MAC address. So it would
Yeah,
believe that
you won't get the
the
MAC
MAC
address
address
of
is
these
filled.
things. Yeah, you'll all for all the IP, even for host C and host D, you'll get the same MAC address, that is 0000C9436AB. So you'll think they all have the same MAC address, but that is not true. The router is just being helpful to you, acting as a proxy. That is why it's called a proxy ARP. You get the point?
Yeah.
Okay. Okay, guys, I'm just going to put the link in the chat window so that you can read this again. Read this again. You just read this paragraph, and it will be clear to you how it is working. So that would be very helpful. Just remember the router is sending you the MAC address of itself because your broadcast cannot travel here, and the router knows how to get to these guys. So he's basically acting as a messenger, and once he gets once you send a packet, he sends it to these guys, and these guys, when they reply, he sends it back to you. So that's it. That's all about Proxy ARP. So we've just completed Proxy ARP.